welcome you to Groton Local Energy Group's 7th seminar in their series. It's designed to present energy-saving ideas and technologies to local homeowners. Tonight's topic is geothermal heating and cooling systems for our homes. And from the days of cavemen, it's been very obvious that a few feet below the surface of the earth, we have a temperature that remains consistent year-round, and technology is now able to take full advantage of this at a time when we are looking for energy alternatives. So we are fortunate tonight to have two speakers on geothermal systems. Our first presenter is Val Prest, a resident of Groton and a civil and structural engineer who has designed and supervised the building of his own home. He's going to tell us the story of some of the choices that he made in his massive undertaking. And we'd like you to please raise your hand if you have any questions during his presentation. And let's please welcome Val Prest.
Thank you very much. Oh, that's nice. Yes, I did do my own house, but I don't recommend it. I, being a PE, have served architects quite a bit over the years and learned enough to get myself in trouble when it comes to architecture. But fortunately, I didn't fall into the trap on this house because I had been thinking about it for quite some time. Now, she called me Val, and that's correct. Well, that's the reason why people call me Val. And with that, would you go to the next slide? This is the house that I built, not Jack, but I did. And it's styled after chalet. My wife's cousin lives in Switzerland, and we visited him. And while they were going around looking at all the wonderful sights, I'm traipsing around the places, taking pictures of all of these chalets to see what it's going to be all about. I researched it. A chalet goes back about 3,000 years to the Chinese in the Himalayas. So it's not a new style, and it's not a Swiss, strictly Swiss. It goes back before the Swiss took it into their country, embellished it, and improved upon it. Why is it nice? It's actually built for solar. Why? Well, why do the Chinese wear the hats with the big brims? Why do you wear baseball hats and pull the visor down on sunny days? That's the very reason why that's efficient, because in the winter, the sun is a low angle, I get heat in there, I get heat in there. In the summer, when it's hot and the angle is high, I don't get so much heat in there, I do get the heat in the lower windows. Therefore, my heating system, or cooling system, in the summer doesn't have to work so hard. So there's an efficiency into the so-called hat that sits on top of the house. It is heavily insulated. I have R50 sandwich panels on the roof. They're 12 inches thick, which means I have a layer of OSB on the outside and the inside, and 11¼ inches of insulation between them, so 2x12s fit nicely along the perimeters. The walls are 2x6 studs with blown-in insulation, and on the inside face, instead of using polyethylene directly against the studs, I added another 3/4 inch of rigid insulation, and against that goes the sheetrock inside. That gives me an R of about 27 and a very tight house. My son-in-law built this Boyd building. He did a wonderful job. He went around in every single crack, every single penetration, and sprayed in the foam insulation to seal those cracks. When I had it tested, yes, we did this design. Would you move on to the next slide?
So is there air barrier in in the sheathing, or is it on the inside of the house?
It's on the inside of the house via that rigid insulation. And on the outside, I did not put the siding right up tight against the sheathing of the house. I do have the barrier, yes.
Tie deck?
Tie deck, thank you, against the siding, against the sheathing, but I did a standoff of 1.5 inches to the siding. So I have an airspace in there. That way I won't have any rot that will come through, condense on the backside of the siding and start rotting out the siding. And I can keep the paint on without struggling as a result of that. So I do have an airspace in there that works very nicely. At any rate, it's critical, no matter what fuels and HVAC equipment you use to insulate the roof, in my case R30, and insulate the exterior walls 20 or better, mine's around 27. The higher the insulation, the tighter you get the envelope, that is for air leaks, the more efficient the house will be, even for any type of heating system. I had chosen originally to use a hydro air, which is heating the water and then exchange for air going through the house. Why? Because I wanted both air conditioning and heating, and I felt that it would be more efficient to use air where I could do both very easily just by swapping the switches, so to speak. Mr. Oriole will get into that a little bit later. Insulate around penetrations through any roof, attics, exterior walls. Use the spray-on foam. Around doors, if you have again, you all own homes? Hands? Anybody here from the commercial or industrial interest areas? Okay. All doors, if you take the trim off, you usually find an air gap between the rough opening and the casing of the window or the door. That's a place where you get air leaks in and out. You can spray foam into that, trim it down, put your finish back on. You're tightening the house. Down at the bottom of your doors, weather stripping, very important. You're trying to minimize the amount of air that passes in and out of the house. I don't have a fireplace. I don't want to chop wood. I don't want to take out ashes. And I have such a small piece of property that I take out a bucket of ashes and I feel like I'm filling up my whole yard. That's how small it is. I only have less than 1/4 acre. What you want to do is obtain the lowest possible Energy Star rating. And that process measures any and all leaks that you haven't plugged up. What do? They put plastic over the door opening with a hole in it and a little duct, and they suck on the air to see what kind of flow they get. Well, they had a 4-inch, they had an 8-inch pipe, to start with, and they were pulling air on it and they couldn't get any flow. So their meter wouldn't measure. So they had to pull it down to a 4-inch duct before they got some flow. They run it through their calculations. You have to have a rating of 85 or lower for Energy Star to give you a certification. Mine came in at 44. So it was one of the lowest, they told us. Next slide, please, that they had witnessed. Ventilation, my house is tight. You can pollute yourself if you don't ventilate because it's so tight. So I had to have a ventilation system. And I was planning on a separate ventilation system along with oil or gas-fired furnace. I had all my plans done, the construction was underway, and I said, Val, the cost of oil has gone up again. You're stupid if you don't look into all this water around you. You should, well, okay, dummy, go investigate. So I looked up geothermal on the internet. I suppose everybody knows what the internet is today. This old man was learning more and more as time went on. What I found was that geothermal has a numerous has numerous ways of accomplishing geothermal and heat extraction. And I had read about one that said it was a standing pipe system, and I said, what the heck is this? And I found out that it was a Mr. Oreo. I don't know, Martin, what's your dad's first name? Dr. Oreo is all I know. Art?
Carl.
Oh, okay. And he invented this standing pipe system. And I said, okay, what is it? Well, instead of having a little pipe that goes down inside of a big casing with a closed system, closed loop system, very common, you put in glycol for antifreeze and you do a heat exchange, but you're only getting it through the wall of the pipe. Here I was taking the water right out of the ground, running it through the heat exchanger, and I'm saying, it makes sense to me that I get more exchange as a consequence of that. So I said, let's go that route, I said to myself, and I called on them, energy. Okay, now, water energy distributors. I'm good at remembering things, yes. My memory is terrific, it's just very short. At any rate, I called them, and they had to actually get a letter to the Board of Health so that they would understand what it's all about and approve it, because it hadn't been approved in this area. So, okay. Well, they succeeded in getting it approved, and I said, oh, well, that's great. Another little roadblock taken care of. So I decided I'd go that route. I'll let him explain it later. Lighting and appliances. Well, I wanted my house to be efficient. My son-in-law had finished his house. He's an Energy Star builder. He used all Energy Star appliances, lighting, etc. So he went ahead and suggested I do the same thing. And I said, well, he's a youngster, he knows what he's talking about, this old man will follow through. So I had all Energy Star lighting and appliances put into the house. I found out through Bill Wenzel, who was recommended to me by Energy Distributors, Energy Water, okay, yes. They recommended Bill Wenzel. What a terrific recommendation. I used Bill. He helped me choose all of the things that I needed. And he said that all of the elements that he was suggesting to use are all Energy Star rated. So even the heating system, the heat exchangers, all Energy Star rated. I said, well, okay, that means I'm doing the whole thing. Next, yes. There's, what you see there is the heating system, and this is I've got 2 water tanks at the suggestion of Bill. This is the first one. It's a small 40-gallon. The water comes from the heat exchanger into that, having raised it up to about 65, 70 degrees via the geothermal heat exchange. It then passes over and comes into an actual electric water heater, which it's 80 gallons. It brings it up the rest of the way to 110, 115 degrees for use throughout the house. That's domestic water. Because I had some arsenic and manganese in it, I had to have this installed, the filters. The chair gives you an idea. It's not that my wife has isolated me to this spot. This gives you an idea of scale so that you know what's going on. And the system is so good that that little right there is for the condensate. And one day the furnace quit. And I said, what's wrong? So I went down and I fiddled. I called Bill. He couldn't figure it out over the phone, sent a man out. The man said, there's no power to this. So we checked it out and he was right. It was plugged into a dead outlet, so I had to get the electrician over. But that little instrument has a float in it. And it shut down the whole system so I wouldn't have my basement flooded with water. Now that's what I consider thinking by Bill Wenzel. But that gives you an idea of the level of thinking. Next slide, please. We're going to be on the other side. What I didn't mention was you saw this huge duct coming down. Air passes through the house. It goes out on the supply side, the same size as a conventional air system from the heat exchanger. It returns, at the same velocity. But if you're going to have efficient air exchange, you've got to open up the ductwork so the air slows down and has a time to pick up the energy from the heat exchanger, and then it goes back and circles around. The water from the well comes in here. It rises up, passes through. This is a pressure tank. It splits off right here. So their system, standing well, gives you both heating and domestic from one source. I thought that was pretty neat. It's not separate entirely. It's not a closed system. The water goes on to the filters from there. Here it comes back, passes through another filter, so it's keeping the heat exchanger clean. It comes down this pipe, follows through here, enters into the heat exchange, does its work, comes out through here, rises up in this pipe, and it comes down to here, and it says, well, I've got a choice. I can go this way or I can go this way. Well, this valve in here is for a buried pipe. I made the pipe run the whole length of the house because I have about 2 feet of heavy stone, 2 3-inch stone underneath the slab. And that gave me a lot of voids. And they need what they call a bleed off. And so that's what that is representing, is the beginning of the bleed off. And they take 5% of the water that's returning and bleed it off here. The rest of it takes the action and goes back out, dumped into the top of the well. No second pipe. Goes into the top of the well. The well I had drilled was designed to go 700 feet. I got down 250 feet and I had it hit an aquifer, aqua water. And initially it was 100 gallons. The further they went down, the higher it got. And we got down to 300 feet and I had 400 gallons a minute and I decided we couldn't go any further. So that's where that stopped. So that's the path that the water is taking, and it's a single well. Wonderful. Thank you, Mr. Oreo, Dr. Oreo. And next slide. That's just more of the same, and you're seeing more of the piping. This is the Ven Mar. I mentioned needing to have air exchange and ventilation in the house. This is an economizer. The air is for the house is coming in and going back out with the makeup air in it. This is exhaust and supply. From the outside is exhausting air and it's bringing in fresh air. So there's where we're getting the necessary heat exchange for purifying and having safe air inside. This also does heat exchange. So whether you're bringing in hot air and cooling your house and sending out air that's a little bit cooler, you are getting some efficiency in exchange of temperatures. In the winter, cold air is coming in. The exhausting air is tempering that so that when it starts into the system, it's not frigid cold. So I'm getting efficiency again in the heat exchange. Next slide. Bill Wenzel, at their suggestion, did all of the installation of the heating and air conditioning. He made this suggestion for the equipment that I use, the 40-gallon and 80-gallon water heater tank, the Ven Mar energy recovery ventilator. He has on that large duct that you saw in the earlier picture a ultraviolet germicidal lamp. So as the air is passing by, I am purifying the air with this UV element. And he designed it for 2 separate zones, 2nd floor and 1st floor, so that I've got 2 thermostats that control it. And all winter, the lowest temperatures that we had, Wendy and I were at the 70, 72 degrees, very comfortable inside, and we had no issues. When we first moved in, that was the hot, sticky season, we had 70, 72 degrees of nice, comfortable air, no humidity, and so it worked out very well. Before you ask me about humidity, do you have to humidify this? How many of you this winter walked across your floor and reached out and got zapped? Very few of you. The first time I've ever been in a house where that did not happen to me. And my wife says, don't have the sticky nose that makes it all difficult to talk, to get the colds and everything else. None of that. Bill Wenzel, I said, Bill, we're going to stick an air humidifier? He said, no, you won't need it. I doubted it. He was right. I did not need a humidity inserted into the system. It worked out very well. Yes.
So where did you get the moisture from? Not from the...
Cooking.
geothermal? Oh,
Cooking.
yeah, cooking, okay.
Washing, the showers, and there was sufficient moisture there that didn't all go out the heat exchanger, I mean the ventilation system. It stayed within the house.
The UV light that you have, germicidal lamp, went where and why were you using that?
For purifying the air, because air picks up bacteria from breathing and from whatever other sources in the house, cooking, bacteria builds.
All right.
And what I was trying to do was to kill that property so that I wouldn't have a sick house inside.
I guess you explained that. I'm sorry. Did you check for radon because the house is so tight?
Radon had to be tested, and we came out negative on that. We didn't have any
Great.
problems with radon.
Super.
Yeah.
Yeah, thank you.
Yep.
So how did you handle ventilation with the bathroom, stove?
The ventilation is tied into that Ven Mar ventilator. We have ductwork in the 2 bathrooms that pick up the air and with any moisture in it and takes it down and does some air exchange and dumps it back into the system. So any moisture that's in the bathroom, a little of it, 10%, goes outside, the other 90% gets recirculated through the house. Installation the work that Bill Wenzel did included the ductwork and grills and the insulation of the exposed ductwork. His cost for installing, or my cost for his installing the system was just shy of $34,000. Next slide. It's a single well, as I mentioned a few minutes ago. The water line splits inside the house where I showed you. One line goes to the heat exchanger of the geothermal system. The other line goes to the domestic water system. Very nice. I like that very much. The same water. I didn't have to get involved with any kind of backflow preventers or anything else of that nature. I was able to use the same water for both purposes. Heat exchanger utilizes 35 gallons a minute of water to obtain the heat and cooling energy. That's why, and I think this is what Martin will confirm, I ended up having a design of 700 feet of well in order to have sufficient flow to achieve this and also to achieve water tempering, so that when you dump the water cold or hot in the top, it has a chance to temper before water is drawn back up. But when I hit that aquifer, that took away all those issues.
But is the system smart enough to only pump water when it needs it to that?
Yes. It's,
So
I'll
you're
be
not
down.
heating or cooling, it just, the water doesn't flow.
That's right. The heat will come on when the demand says, I need it. And when it does, I hear this, and then the flow of water. And it's not any louder than the water going through your faucet. Very, very comfortable. Yes?
Can you use your existing well for this system?
It depends upon what kind of water supply you've got in that well. And I think if you would, Martin, address that later.
Absolutely. Okay.
I see you're within 100 feet of the buffer zone for the, or within the 100-foot buffer for the lake. Had you thought about using the lake for your geothermal?
I did, for about 30 seconds. Because I've been before the Conservation Commission, not just for myself, but because of my business, I've had to go before it for many clients, not just in Groton. And they have their own set positions on things, and so I said, no, I'm not going to go back through that process again. So I said, let's go down with a single well, and as long as I stayed within my footprint with my discharge, That's the part that goes under the slab. I had no more need to go before any board because it was within the footprint of the house.
Do you know if the Conservation Commission has dealt with geothermal in a lake or a pond or a river?
No, I do not.
Okay, all right.
And this is where we were talking about it a few minutes ago. I hit 400 gallons at 300 feet. So I had plenty of water, yes.
Val, was there anything unconventional about your well? Because the cost is a little on the high side. Was there something?
They were expecting to go down to 700 feet. And what happened was that when they got down to 150 feet, they had to pump water out in order to drill deeper. And there was no place to put it. I could not dump it into the lake because it would have all kinds of mud and everything else with it. I had to keep it on my property. They took backhoes and dug these very deep trenches, and they filled them up in a half an hour. And they said, well, that's not going to work. So they bought on site the biggest dumpster they could find, and they filled that in 2 hours. And the water was squirting out through the joints on the door to the sides of the dumpster. I said, I gotta find out what to do. So I called the Oreos and they said, oh, stop, you're in an aquifer, don't go any deeper, you don't need to. And I said, oh, bless you. And I stopped. And the cost was in that digging the trenches, bringing in the dumpster, handling all the excess water. So my cost was a bit higher because I had to deal with all of those unexpected, as they call it, unexpected issues. I have cost for the geothermal was the cost of the system. You saw that on the previous slide. The cost of the well is $10,000. The total is $44.90. Cost of a conventional alternative, when I first looked into all of this, the water well would have been shorter. It would have been like 200 feet down, and I would have paid $4,500 for the well and all of the appurtenances that go with it in order to make it a useful well. The cost of that well would have been about $4,500. Had I gone with an oil and gas or wood burning, whatever, that system would have been somewhere in this neighborhood for a total of $23,500. So you take this from this, and you've got this additional cost for geothermal. How good is your memory? I want you to remember that number. Yes?
Val, I wanted to ask, because I'm not that familiar with your specific install, did your 23.5 include air conditioning and the Ven Mar system?
This 23.5,
Yes.
that,
Heating and Ven Mar?
it was not for a Ven Mar. It didn't include the Ven Mar. It included just a ventilation system. The Ven Mar I learned about when I was talking with Bill Wenzel.
But that does include air conditioning system?
Yes.
as well?
Yes. Yeah, at the time. So I'm going to have to trust on your memories. You saw mine here earlier. It's not that good. Next slide. Other decision factors. My entire lot, less than 1/4 of an acre, the whole thing is within the 100-foot buffer zone. It's a peninsula. We did not want oil on the property. That was my decision because of what I was faced with the Conservation Commission. They were very fussy, even when they came on site and saw my son-in-law with an air compressor in a 5-gallon can. She made us put a total barrier on the ground with curbs and had to keep everything inside of that. It's amazing. If she ever came down and saw me dumping gasoline into an outboard motor, she'd have fainted. We did not want oil on the property, and as you all are finding out, it's getting more and more expensive. We have little to no room for a large propane gas tank, and our neighbor has a large tank, but he's got a large piece of property and he hides it behind bushes. Coal and wood-fired system, labor-intensive, messy on cleanup, need waste disposal. Electrical resistance heating, too inefficient, too expensive to operate. That's the reason why I was looking into geothermal. Next. We moved in on the 3rd of August last year, and that was the last small bill that I got from the electrical company that was paying for the electric that my contractor was using on building the house. When we started there, that's a sticky month? Yeah, it sure was. Our first invoice for the electricity, now mind you, this electricity is running everything in the house. The lights, the stoves, the oven, refrigerator, dishwasher, washing machine, dryer, and the heat exchanger, and all of the lights throughout the house. That first month, $124. The next month, $168. So you can see it was kind of staying fairly steady in here until we started encountering cold weather. And then it started climbing again. By the way, when I chose geothermal, I looked up to see if I could find any kind of tax benefits or other benefits, even from the electric utility company. There were none. If you had solar, you had wind, you could find all of these paybacks from the government. For geothermal, none. And I says, I don't care. I'm going to get some savings anyway. So, go on to the next slide.
Of the February and March, I'm sorry, how much of that might be attributable to geothermal? That is, do you think the additional costs were because of the additional pumping that was required?
There was 2 reasons.
Oh, okay.
One was the fact that there was additional water being used and the heat exchanger had to run more frequently for heating than it did for air conditioning. The other one was that I had just completed connecting a water heater to a radiant slab in my workshop. Now I keep that down fairly low, 60, 62, until I walk in there, and then I'll turn it up. But at that time, when it made the jump from here to here, it was reflecting not just the cold weather that we had, but also that I was working in my workshop and I turned the temperature up, so I was using electricity for the water heater to cycle under the slab. Next slide, please.
One question,
Yes, sir.
you know up here what your square footage living area is in the house?
In this new house, the footprint is basically 40 by 28. And it's 2 floors plus a basement. So if you said 30 by 40, you're 1,200 square feet. For the 2 active floors, that's 2,400 square feet, and another 1,200 for the basement, which gets infrequent use. Yes? Slide, please. Heating with oil. I went on the internet and found out what the price was for January, and I ran through the numbers on an estimated basis. I had gone in and picked out the BTU per gallon that I could get out of it and the amount of volume that I had to heat. And so on the handout, you see the calculations very completely. You don't see it on the screen. But it came out to be this in the gallonage per month, translating into this at $3.46 a gallon. I'm hearing numbers that are much higher than that now. And the non-heating electricity, which would be for the lights and the washing machine and everything else, all the appliances, would be $124. So the cost per month for oil, heat, and electric is $1,000, and the total estimated for the electric per year, because what I did was I prorated it on the amount of oil that I would need as the seasons changed, and I ended up with a total of $5,871 for the same thing on geothermal. Mind you, I haven't been there a whole year yet, but I was getting a good idea from those prices that you saw before. My cost will be $2,278 a year for a savings of $3,500. And when I took that other number that you were supposed to remember, hey, good memories. Divide it by that net savings per year. And I pay off that whole $20,990 in 6 years. After that, I am golden. And my oil isn't rising. My electric bill will rise if they're using oil to generate the electricity, but that's spread over a huge base. I'm not the only one. So that's why I am very happy with what I've got. Thank you very much.